Hello everyone, welcome to my Semester 2 project overview video for my Engineering Architecture 3 class at Joliet Central High School. I'm Jose Lara and I will be narrating you through my two major projects I've done this semester, and I'll provide an explanation for my projects, design choices, and choice insights, and the reflection for these projects individually as a whole and the semester. My first project was the Lantern Project. I began the lamp project by researching different designs that could incorporate 3D printing, laser cutting, or both. The design I would end up going with is on the bottom right, which is a chandelier, a Pokemon. The reasoning behind my choice boils down to me wanting a design that I care about and a design that would challenge me. After picking a design I wanted to go along with, I began drawing concept sketches in my engineering notebook. These sketches were simple renditions of different parts I would have to model. Since the lamp itself was too large and complicated to print all in one go, I'd have to split up the lamp into different parts, such as the head, crown, arms, and body. I also had plans to 3D print a stand, but this part was later scrapped as a whole, and instead a hole was added to the body for the power cord to go through. The way the parts were assembled was by using guiding holes and features in the headpiece. The headpiece would have a smaller extrusion on the top and bottom so that the crown and body would align correctly, and the body would have holes for the arms to go in. The way the lamp would be held together would be through the use of adhesives. Here are all the parts I modeled. I used a revolve to create most of the features of the head and used a revolve to create the body entirely. For the crown, I utilized an array and for the arms, I utilized a spline tool to make the curved shape. I assembled the models together and made an exploded assembly to show how the lamp was to be constructed. I changed the design of the body piece to be shaped to be better suited for the light bulb. After finishing my 3D models and assemblies, I got quick to work on 3D printing my parts. The only notable thing to discuss about the printing process was the head. For the head, I had to 3D print in three separate colors. So in Bamboo Lab, I used material surface detection to change the surfaces to a different filament, so when I brought the file to the 3D printer, I could 3D print it in three different colors. After everything was printed, I took all the parts home and glued them together, using the aligning features on the head as I mentioned before. One thing to note was that the arms had tree support residue by the way they were printed. So what I had to do to circumvent this was to sand down the pieces and paint them black to cover up the discolorization caused by the sanding. After the arms were done, I glued them to the body overnight. I glued the arms by standing them up and used objects to hold them in place while the glue dried. Overall, my final product turned out great. The only thing I would revise about the project was the arms and the arm holes in the body. I would change the tolerances between these two just so I could avoid using as much glue as I did. My second project was a team-based project with my classmate Juan Rosiles, and the project was the Skills USA Illinois Additive Manufacturing 2026 problem. For this project, Juan and I were tasked to design a fully 3D printed catapult or trebuchet that could launch a Lego minifigure as far as possible while being precise and accurate. Overall, the types of things we had to consider for our design was our design's ability to hold elastic potential energy and use it to launch a minifigure. Our design had to have a launching mechanism that allows the mechanism to launch without us physically making contact with the launcher arm, and our design had to be stable, meaning that it wouldn't break after every launch. For our research, we looked for parts that would help maximize the elastic potential energy of our design. Things such as flexibility of parts, thickness, and different kinds of mechanisms like leaf springs and the overall shape of our design will aid our goal to figure out what components we could incorporate to our design so we can maximize torsion while also being able to spread that torsion across the body so the design doesn't break. Of course, we also did research on different kinds of launching mechanisms we could use and different kinds of launcher arms and bucket designs that would better hold the Lego minifigure. For our sketches, we sketched the most important parts of our design. That would be the base, launching arm, bucket, side arm supports, leaf springs, and the pieces that connect the arms together. As soon as we got into modeling, we made a couple of changes to our parts. The triangle support piece received an incline. The incline would provide the Lego minifigure with more airtime, which would allow us to travel further than before. The connector piece on the bottom left is roughly the same. The only difference is now that the part is separated from the base, while the leaf springs, connector rod, and an arm did not receive any changes. Those would be the images in the middle. The launching mechanism that we decided on would be a sliding release trigger. The way it works is that a piece would grab onto the launching arm and hold it into place. To launch the arm, you would have to slide the piece away from this arm. As for the launching arm, the bucket of the piece changed from being a large, wide rectangle to a more box-like shape. It saves on space and it can hold the minifigure sitting down. After everything was printed, Juan and I assembled our design and began testing it. An issue that we came across was the assembly would sometimes lock. This was due to the tension from the leaf springs, which completely overwhelmed the design and caused it to lock up. The fix was to readjust the design in the way it was assembled, by making sure the arm was pulled back correctly towards the trigger mechanism. While this made the design functional, the tension was too much, and Juan and I had to test to see if this abundance of tension is affecting the performance of the design. As a test, we designed another launching mechanism piece that was sloped and much longer. This alternative design would help pull back the launching arm back less, and in turn decrease the amount of elastic potential energy in our design. Testing involved setting the catapult up at a starting point and launching it and marking it where the Lego figure landed with a sticky note, and labeling it with its trial number and distance. After 10 trials, 5 with the original design and 5 with the other alternative design, we found that the original design, which was the shorter one, had the best distance, meaning that the tension did not hurt our functionality of our system. Juan and I's project turned out great. It was functional and able to launch a Lego minifigure about the average of 9 meters. We were proud of our design and learned a lot about a team collaboration and communication through this project. Although, one thing to keep in mind is that our design was not exactly accurate or precise, so if we were to retry this project again, we would focus more on those features of our design, making sure our precise has less variability so that it can be more precise and accurate. I finished up the semester with 2 smaller projects. My first small project was modeling and drawing the Skills USA Illinois 2026 technical drafting problem. I modeled, assembled, and made drawings for the different parts of the problem. For my last project, I was asked to design a Science National Honor Society magnetic pen for club officers. The design is composed of hexagons at different heights with text that extrudes above it all. I plan to print this design using 2 different filament colors. Now that I reviewed all my projects throughout the first semester of Engineering Architecture 3, I'd like to reflect on my performance of the semester as a whole. My time management of this semester was a massive improvement compared to my first. I was able to retain more focus for my projects, especially the additive manufacturing problem. Another thing I'm proud of is my creativity of my lamp and just the overall rigor of the project I've done this semester. The projects that I did this semester challenged me in many different ways. The lamp project challenged me on modeling skills and pushing an inventor to its limits, and my additive manufacturing problem challenged me to my engineering notebook documentation skills that I've been building since the beginning of the school year, and my teamwork skills. But one thing I'll have to point out is my motivation. My motivation at the beginning of the semester was high, but it quickly diminished after Skills USA, which was late April. My lack of motivation explains my rather simple final projects. Well, that's all. That was my semester 2 overview and reflection. Thank you for watching.